Okay, we're going to go over the quiz from week 4, which was transcription and translation. Now, up until week 4, everyone was doing pretty well on the quizzes. Now, in week 4, the average went down a bit. So the average for the week 4 quiz was only a 76. Not bad, but it does indicate that some individuals had trouble with this material. So again, as I've said before, if you had trouble with this quiz and it's just because you didn't study enough, go back and study this material. If you had trouble with the quiz because you didn't understand the concepts, that's a little bit different. You're going to have to work a little bit harder to see what it is you don't understand. Post some questions on the discussion board and I could try to explain in more detail. Go read your textbook. I can give you some suggestions on other textbooks that you might want to read on a specific area or topic that you're having trouble understanding. We could set up a telephone or an instant messaging session and I will try to explain things in more detail. So again, I'm only going to go over the questions where less than 60% of the class answered the question incorrectly. So all of these questions, at least 60% or more answered correctly. But I'm going to go over a couple of questions where it was only 60% that answered them correctly. So there was a question asking what statement was correct. And the statement was regarding transcription and the direction. So during transcription, an RNA is transcribed in the 5 to 3' direction. That was one answer, and that's the answer that 60% of the class answered, and that was the correct answer. The other answers, during transcription, the template strand is read in the 5' to 3' direction. We're going to go over these. Another answer was during transcription, the template strand is read from the N terminus to the C terminus. That one cannot be the correct answer. And the reason is you only use the terms N terminus and C terminus when you're talking about proteins. You never use that term when you're talking about nucleic acids, such as RNA and DNA. For RNA and DNA, it's 5' to 3'. For proteins, it's the N terminus and C terminus. And during transcription, the template strand is read in both the 3' to 5' and 5' to 3' directions. That is not true. No one answered that, so that was good. So whomever answered the N terminus to C terminus, just keep in mind that's protein. And the two that everyone was, well, not everyone, but some people were confused about is RNA transcribed in the 5' to 3', and is the template strand read in the 5' to 3'? Well, when you're talking about transcription, you always want to remember how DNA is replicated. So here we have a double-stranded DNA. We have the 5' and to 3' strand, and then a 3' to 5' strand, because remember, they're anti-parallel to one another. So when your DNA is going to be replicated, it is going to make a fork. Now, one strand, your 3' to 5' strand, is going to be read continuously. So DNA in transcription is read in the 3' to 5' direction, but it's transcribed in the 5' to 3' direction continuously. So the 3' to 5' strand is going to get copied in a continuous manner. Now the 5' to 3' strand is going to get transcribed in pieces. So you have your So remember that this is 5 prime. So right here would be 3 prime. You make that little primer with primase and you get then your Okazaki fragment. Again, you're going to make a little primer and an Okazaki fragment. And as the double strands separate more, you're going to keep getting these small little fragments. Ligase is then going to come in and seal up all of the little Okazaki fragments, and you are going to get duplicate double-stranded DNA of your single double-stranded DNA. So there are videos on the Blackboard posted, the links, that really give a nice animation on the replication, transcription, and translation process. So I'd really recommend going in and watching those if you have not already. So this one, RNA, is transcribed in the 5' to 3' direction. Now, another one that some people had trouble with was during peptide elongation, the charged transfer RNA is added at the, so you remember you have your ribosomes, your RNA, your large unit and your small unit, and you are going to add the next peptide at the A site, and your transfer RNA comes in and adds your peptide at the A site. The ribosome then moves down to the P site, and another transfer RNA is going to come in and add at the A site. So again, there's great videos, and this answer was the A site of the ribosome is where you get your transfer RNA adding your peptide. There was only one other question that actually 75% of the class answered this question correctly, but the fact that there were some people that answered this question incorrectly is a bit concerning, only because we talked about this in lecture, and there was one of these little videos that I posted that I actually explained this before you even had to take the quiz. And I warned you of some of the tricks that you need to watch out for during a quiz. So if you're not watching the videos and you're not listening to any of these postings that I'm putting in, you might miss some hints that you might have gotten otherwise. So this question was for the DNA strand. So the first thing you want to think about when you hear DNA is which nucleotide bases should you be considering. So G, C, T, and A, right? You don't have to think of converting your DNA into RNA in this case. So in this question, you have a 3' G, C, T, A, C, A, G, G, 5'. And it's asking you, it is asking you the complementary RNA strand. So what you can do here is you can put in what the complementary DNA is and then convert it. So the complementary DNA would be C, G, A, T, G, T, C, C, 3'. This, however, is DNA. What you want is RNA. So what you would need to do is convert this to RNA. So your T's become U's, and everything else will stay the same. And this, in fact, is the correct answer here. So there was some people that put in the complementary DNA. So you really want to read those questions carefully. Are you trying to figure out the complementary DNA, or the complementary RNA. So if it says complementary RNA, you want to find the answers that have U's in them. If it says complementary DNA, you can automatically cross out any answer that has a U in it because DNA is not going to have uracil in it. So these are the ways you need to be thinking about and the things you need to be considering when you're taking a quiz or an exam. And you are going to have questions like this, these analysis questions, on the midterm exam that's coming up very rapidly. So if there are topics you're not understanding, if this is a topic you don't understand, then post a question or give me a quick email or telephone call. Okay? Good luck.